Find all angles in the domain where theta is between 0 and 2 pi that satisfy the given equation. In part A, we'll solve sine squared theta equals 1 algebraically. Take the square root of both sides of the equation to isolate sine theta. We get sine theta equals positive or negative 1. Bring up the unit circle. Sine theta equals positive or negative 1 when theta equals pi over 2 or 3 pi over 2. If we look at the graph, we can see that y equals sine theta intersects the lines y equals 1 and y equals negative 1 at the angles in our solution. In part B, solve 4 cosine squared theta minus 3 equals 0 algebraically. Add 3 to both sides to get 4 cos squared theta equals 3. Divide both sides of the equation by 4. Square root both sides. This gives us cos theta equals positive or negative root 3 over 2. Bring up the unit circle. Cos theta equals positive or negative root 3 over 2 when theta equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If we look at the graph, we can see that y equals cos theta intersects the lines y equals root 3 over 2 and y equals negative root 3 over 2 at the angles in our solution. In part C, solve 2 cos squared theta equals cos theta algebraically. Remember, don't cancel across the equal sign or solutions will be lost. Bring all terms to the left side to get 2 cos squared theta minus cos theta equals 0. Factor out cos theta to get cos theta times 2 cos theta minus 1 equals 0. Set each factor equal to 0. Bring up the unit circle. Cos theta equals 0 when theta equals pi over 2 and 3 pi over 2. Moving on to the next factor, simplify to get cos theta equals 1/2. Cos theta equals 1/2 when theta equals pi over 3 and 5 pi over 3. The solution over the domain where theta is between 0 and 2 pi is pi over 2, pi over 3, 3 pi over 2, and 5 pi over 3. Let's see how this looks graphically. Graph the original function, y1 equals cos theta times 2 cos theta minus 1 in a calculator. The theta intercepts of the factors will give us back the roots of the original equation. Now graph y2 equals cos theta. This gives us the roots pi over 2 and 3 pi over 2. And finally, graph y3 equals 2 cos theta minus 1. This gives us the roots pi over 3 and 5 pi over 3. In part D, solve tan theta raised to the power of 4 minus tan squared theta equals 0 algebraically. Factor out tan squared theta to get tan squared theta times tan squared theta minus 1 equals 0. Set each factor equal to 0. Square root both sides. This gives us tan theta equals 0. Bring up the unit circle. Tan theta equals sine theta over cos theta, so tan theta equals 0 when the numerator, sine theta, is 0. This occurs at 0, pi, and 2 pi. Moving on to the next factor, isolate tan squared theta by adding 1 to both sides. Square root both sides. This gives us tan theta equals positive or negative 1. Tan theta equals sine theta over cos theta, so tan theta equals positive or negative 1 when the numerator and denominator have the same magnitude. This occurs when theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The solution over the domain where theta is between 0 and 2 pi is 0, pi over 4, 3 pi over 4, pi, 5 pi over 4, 7 pi over 4, and 2 pi. If we look at the graph, y equals tan theta intersects the lines y equals 1, y equals 0, and y equals negative 1 at the angles in our solution set.